here you go. I believe I need to share my screen and share this screen. What happened? Share this one. Okay, can you see my screen? Class, can you? Okay, great. Um, okay, let me go with presentation mode, and these are part of the presentation. I'd like to discuss what ANOVA test, but I'm gonna go with team project first, and then if you didn't have a time, I will explain this on a separate video, and then you can watch that and ask me a question if you have. Okay, the team project. I expected to have most of the team are doing great in my class. I'm not sure about your class, Dr. Azadi, so so you can, if any of your students is here, they can just go ahead and just after this we can answer the question together. Most of my students submitted the topic. I'm sure I know two of teams are doing very well, and two other needs a little bit more work. But anyhow, they are doing well till now. They still have one more week to work on that. The team project is a 5 till 10. This is 10 pages. I say 5 till 10 pages is really, the five is really short. It's a very small part. So we need to at least 10 pages, including the reference page and the um, cover page. So if you're working in 10, 11, 12, this is fine. So because some of the students just say, okay, if you work with 11 pages, it's okay. If you go with 9 pages, okay, yes, this is okay. We accepted the variance, so 10 percentage variance is going to be 12 or 9 or 8 pages. First part of the team project is literature review, and for each literature review, students need to select 3 to 5 peer-reviewed articles and discuss as a summary. Not more than 1 page for each article. So usually in my class, all the team has at least 6 members. So at least 3 of members can work on articles. Each member one article, discuss 4 main section: introduction, very short introduction article, methodology part including the data, research question, type of analysis, and the result and discussion. 4 main parts, 4 or 5 main parts. And after that, you are going to go with a method. In the method section, you're going to discuss on hypothesis, discuss on the data, because for example, a few of you use medical national data by county, you can just discuss 1 paragraph, 2 or 3 lines, discuss what is this data set, what the data set explain, how many variables is that, is there in the data set, how many observation, and is this the data for the US system, which section. So kind of these arguments. Then you're gonna go with the variables. The type of variable you are using is a continuous variable, is a categorical variable, if so, and the name of variable. So for example, if you are going to compare the mammogram between black and white population, you have 2 continuous variable. Each variable is a percentage, and this is a continuous variable. But if you are going to, for example, in the dental access, in the dental in a MEPS data set, you are going to see, for example, how many percentage of population have access to dental care. Having access is a 1, not having access is 0. So you're gonna have you're gonna have a 2 categorical variables. So this is the definition of the type of variables. And then you're gonna go and discuss on the methodology part. In the methodology parts, based on the topic you suggested in my class, most of you have 2 population. The best fit test for the 2 population is a t-test. It is important you address that. Is it an equal or unequal test? Because and my suggestion is go with non-paired t-test, because when you go with paired t-test, some of the observation, if there is not equal observation for each variable, you're gonna lose some observation. Though basically this is a method is a weld sample sample t-test, and you can see the output of the other series based on that test, and then there is document in the class that explain that what is that test. So you can argue that type of the t-test and type of the test you are working, 1 to 2 paragraph is enough for that. You may discuss not more than 2 or 3 lines about the, for example, if you are most of them are using RStudio, what is the RStudio and why you are using this, and kind of this information. It's very simple part. And then you're gonna go with report your findings as a descriptive statistics, number of observation, mean, standard deviation, and then you're gonna go at and show the distribution of your data using a boxplot to show the means of the two variables, and you are going to use the density plot to see the distribution of data across two variables. Specifically, if you are working with a continuous variables, the density plot is good. If you are not working with it, then with continuous variables, basically you cannot go with the density plots. So you can explain that I did not go with density plots because of what, and because of these reasons. Okay, and then you're gonna go and test the hypothesis. I say that using the t-test, and then you're gonna go and write the results section. The results section, I expected to see 2 or 3 paragraphs. One paragraph explain about the mean distribution. For example, I'm going to explain the percent of black population and white population having mammogram, and then you can say, okay, the mean distribution between white is a alpha percentage, the mean distribution in the black population is a beta percentage, and then there is a variance between them, which is standard deviation of, for example, x and z. These are kind of discussion for the descriptive analysis, and then you can say, okay, I use a Medicare national data by county. This data set, for example, has 3,000 observation. For my observation, I use 1,500 white, 1,400 black population. These are, I'm just making just some numbers. It's not the real numbers. And this is for this, and then you're going to go and discuss the t-test result. If the result is more than 0.05 percentage, you can't see any significant differences between these two. If there is a less than t-value, as a p-value is less than 0.05, then you have significant differences, and then you can say, okay, there is a significant difference, and you between, for example, in my example, between black and white population, and then you're gonna discuss, are you accepting, or you are rejecting the hypothesis. Then after, so till now you have all section, you have the literature review, you have the method part, you have the result, and then you are in a situation to discuss on a few policy recommendations. I expected at least 1 or 2 policies. Depends on the topic you are working on that. You're gonna go and suggest a policy. For example, if there is a racial disparities between black and white population, and so a policy should be, okay, we need more resource. For example, for the population, they are not receiving the equal utilization. So you can, for example, if the usually black people suffer more from in comparison to the white, you can say, okay, maybe we need to spend more resource on that. Or if you are, for example, going to compare the dental between young and older adult, and you can say, for example, and you can see lower utilization in younger adults, so maybe a policy should be allocating more resource for younger adults. These are kind of policy. And then abstract is not okay. And after the policy recommendation, our policy recommendation is part of the conclusion. The conclusion, I don't expect it to see maximum 2 paragraph, 2, 5, 10 lines. Even one paragraph is better. So the policy recommendation should be the last pieces of the discussion. At the very end, at the very beginning of your assignment, you are welcome to report abstract. It's not a requirement, but if you like to do that, you can have an abstract like four main pieces: the structure of abstract, 2 lines for introduction, discuss your topic, 2 lines to discuss the method part and data, and 2 lines for result, and finally 1 line to conclude your abstract. It's gonna be not more than 10 lines. Usually abstract is between 120 words till 150 words. Very short, sweet abstract. Okay, till here, this is instruction for that. Do you have any question here? Okay, if not, I'm going to walk through an example. Okay, this is an example for usually you need to answer 6 questions to run the analysis. The first question is, what is your research question about? For example, my question is there any racial disparities between black and white women who receive mammogram? This is my question. Based on this question, I'm developing a topic. My topic will be comparing average percent of female Medicare enrollee age 67 to 69 having at least one mammogram over a 2-year period between black and white. So the topic gives me more details. So if you look at this topic, in this topic I explain the population. I'm going to compare the percent of female, and I'm gonna go with Medicare enrollees. I'm also giving some information on the age. I'm going to only compare 66 to 69, and I'm going to utilize only mammogram over 2 years, and I'm going to include only 2 racial groups, black and white population. So these are all the information you can get from this topic. Also, these topics give you 2 things. The first is the data sets. Based on this topic, you can say more likely you are going to use Medicare National Data by County. And then, do you know the name of variables or no? So whenever you answer these 2 questions, you are good to go with the RStudio. Okay, if you have, so for now, if I go back to here, do you know the data set? Yes, I have my data. Yes. Yes, do you have any question? Okay. Okay, please mute your phone. Okay, it was not question. If you know the data set, but the question is your data set in a CVS format? If your data set is in the CVS format, then you can go and with read.csv command and then read the file. Let me try to mute. I don't know who is. Okay, I'm gonna mute. Oh, okay. If you know your data sets, you can go with read.csv. In week 1, 2, and 3, you already are familiar with reading the CSV. You need to identify the place of your file in your computer. I suggest you just copy the file in drive C of your computer and put it on the UMUC folder. If you are working with Mac, and you have the Mac should be a /documents, and if you have a documents, you can generate a folder and call it UMUC. In the Mac should be tilde. I will explain here. In the Mac should be tilde. Let me here. If you are working with MacBook, and this command should be something like this tilde /documents /UMUC, and documents should be something like this. That's it. This is the differences between Mac and Windows. So when you read your data, so the question is, sometimes you are using, if you choose any topic I suggested, most of the topic have the CSV file, so you don't have any problem usually with that. But if you are using, for example, some students are using the maps dataset, and the maps dataset, the data is in a Excel format. Basically, the read.csv is just for using the CSV file. So what do you have to do if you have Excel file? Any suggestion for this? Okay, if you have Excel file, you need to convert your data set to the CSV file. There are several steps you need to follow. The first step is, in the CSV file, you need some of the CSV file using this separator. For example, for the numbers, if there is more than 4 numbers, after third one you can see kind of this symbol, comma. So basically you need to convert your data set. Let me open Excel and show you here. You need to convert that to the original file. Let me give you an example. Okay, for example, I have this numbers, and usually some of the file using this format, number format, and for each number there is a separator for 1000. This data you have, for example, this data set, kind of this, or you maybe don't have even the decimal here, but you still have this file. If you read this file, if you consider you want to read this file through the RStudio, the RStudio consider this as a string file, and basically for the string file you are not able to do anything, because in terms of the RStudio there is no differences between 100,000 and my name. Those of them are string. I'm receiving a message that probably we're gonna this session will be stopped in a few minutes. I think it's still I'll be in 10 minutes, so we have 10 minutes to go, and then we can start the second session. Before I'm forgetting that in the previous session some students didn't go back because they didn't connect to the session. The link I send it in the posted in the class or email to you. There is 2 links. Please go with the second link for the second part of this class, this live session. Okay, what you need to do to convert this file, you can click on the column to make sure. If you have 10 columns, you can click all the column, and then right click here and go with the format cell, and then put it as the general. Say okay, this is the number now, there is no separator here, and then you need to save as this file. I'm going to save it in the CUMUC. Click here and CSV, comma delimited. I'm going to put it as a test. This is what you have to do here. Okay, this is the file for the files that are not Excel, are not CSV file. And if you look at the data in data setting class, sometimes in the data set in the class you have the 1, 2 and the third row as a information about the data sets. Basically, if you convert this file to the CSV file, CSV consider this one and this one as a variables, the first cell for the variables, and then you are not able to see the data. And for example, if you try to open an Excel file, probably you can see as x1, x2, x3 and x10, depends on number of variables you have in the data set. So for that reason, If you decide to work with Excel file, make sure to remove any text before the variable's name. Any number, any text. For example, here, if I want to convert this to the CSV file, I'm going to remove the line 1, the row 1, the row 2, and just stay with row 3. It is recommended always to use a small name for variables. For example, don't use, for example, the explanation of the mammogram between white and black. So you can just say W mammogram, white, B mammogram, black, white. Very simple explanation, very simple name for the variables. Okay. So if you have the variables, whenever you have the data sets, so you are similar to the CVS file, you can just go ahead and just read the data sets. After reading the data sets, so do you know, did you ask your question, do you know the name of variables or no? To see the name of variables, you can run this command, names data, and then you can see this. For example, I'm reading the data from Medicare National Data CSV file, and these are all the variables in the data sets. For my topic, I'm looking for these two variables, percent of mammogram black, percent of mammogram white. These are two variables here. Let me put in the presentation mode. Go ahead. You know, if you are working with in the class for imaging file, for the Medicare National Data by County file, and for the Minnesota data, I converted them already to the CSV file. So if you use them, you don't need to. Please look at the instruction, I put a link, and if you use any of them, so you don't need to convert to the CSV file. My explanation was for some students they are using different data sets, and say they need to clean the data first. This week discussion was about the data preparation. We need to follow 5 main steps to make the data clean and ready for analysis. The data set in the class, except for the outliers, I keep the outliers in some of them. Just make sure you are paying attention to the outliers. You do not need to convert them to the CSV file. It is already in the CSV file. Sure, you're welcome. Okay, and then I'm going to the name of the variables. Name of the variables I need here is a percentage of mammogram black, percent of mammogram white. So then I need to use 3 different functions. The first function, number 4a, is a mean function. This is the mean, this is the name of data, this is the dollar sign, and this is the percent dot mammogram dot black, the name of variables. The same for the white, and I can see the means. In the next section I will explain, I will go to the RStudio and discuss on this. The next function is a standard deviation function. I can use the same means function, just change the mean to the standard deviation. So you can see the SD function and see the standard deviation. I have 3 more minutes to discuss. Hopefully I can finish by that time. Then so now I have a mean standard deviation. I need to see the number of observation. The number of observation, you can use my table command. The my table command is started with my table, this sign, table, dataset, $, name of variables, and then you need to use the summary command to see the observation. This is for black and this is for white. Till now we run 3 commands. mean, standard deviation, and my table comments. And then the last command is a t-test. The t-test is to check, is to approve or reject the hypothesis. The hypothesis here was, is there any significant difference between black and white population or not? I'm running the t-test. The t-test is a command here. This is the name of data. This is the variable for black, and this is variable for white. And now I say, okay, remove, consider if there is any missing data in the file, just consider them as a missing data. So the data set, and if I run this command, so you can see this output, wedge to sample t-test, I can see the p-value here 0.0118, 0.0018. So this number is less than 0.05. I can conclude that, for example, this is 60 for black, see, black, and this is 61. These numbers are very close to each other, but even they are close, there is significant differences between mammogram between black and white population. Okay class, I have 1 minute and 5 seconds. I prefer to stay here, answer one question, and go for the next section, because I want to explain the P and the box plot in the next section, and then I don't like to stop in the middle of presentation. Okay, let's stop here and go back with the next section, because it's gonna be disconnected shortly. Okay class, see you very soon. I have to disconnect this one and back. Okay, class, make sure to connect with the next section. Goodbye for now. What's happened? What is this? Okay, here. Start. Okay, hello again class. Are you here? Okay, wonderful. Okay, let's wait a few seconds, make sure everybody's here, and then go with the next part of the codes. I'm recording that. I will post in the class. You're welcome. Yes. Mm-hmm. Mm-hmm. Uh-huh. Okay. Okay, thank you, Dr. Azadi. Any other question? Okay, no questions. Okay, sure. Okay, are you talking about the instruction we posted in the class or the template I explained now in the presentation? I'm okay. Okay. Dr. Azad, is it okay if your student go with instruction in the PowerPoint also, or no? You stay with your instruction in the class. Okay, it's 95% is the same, but some student want to exactly go with the instruction in the class. Okay, great. Amanda, is it okay with you? Did you get your response? Okay, wonderful. Okay, thank you, Dr. Azad. Any more explanation? Sure. Yes, because most of the student has some question with factor variables. The way happening is I will go to the exercise 3 when I finish this and explain that, because the most problems you welcome in the exercise 3 is the order of the running the code. If you go and run one time to go to the very end and then back and work with the code manually, you already converted the Herfindahl cat to the factor variable, and then with that factor variable you are not able to generate a data set. This is the point, but I will need to show them that how they can just go with fix that, because it's happening in my class. I think Vicky had some question with that. I don't know if she's here or no. No, she's not here, but Vicky and other students, Natasha, some of them has the same problem. Okay, I will explain that part too. Thanks. Okay, class, let me share one more time and then go to the second part of the presentation to discuss. Do you have my screen? Class, can you see my screen? Okay. Okay. Okay, it was about the t-test, and then we have, and the second part is the visualization of data. For data visualization, you need to go with at least two plots. Most of you are working with a continuous variable, though this is you can go with that plot. And then the first set is the box plot. Box plot is good plot to explain the mean differences between two variables. And this is these three lines. These three lines are for box plot. You can use for any type of box plots in the world, not even in the data in the class. If you have a data set, if this data set has two variables, and if these two variables are continuous variable, you are good with this code to generate a value, the box plot. So it works with any type of data. If in some points, if you are not able to see the result, the problem is not the codes, the problem is the data. You need to fix that first. So this is the command, boxplot command, open bracket, data. The data here is the same as data here. You are using two data set, but then you need to change this data set to data 1 or 2. But so I assume that you are working with one data set. The current data set has a mammogram black and white, so I put black here, I put white here, and this is the main topic for that plot. This is Y label here, and this is the name for this column, black, and this column is white. And this two name is based on the order of the variables here. If you change it to the white and the black, then you're gonna switch this with this. So This is the point you need to consider. You also need to run all them together, so please don't stop just selecting each line by line. If you select each line by line, you cannot see any result here. Then okay, this is the box plot. This is, you can explain this here. This is the differences between these two means very small, but if you work with another data set, probably you can see the higher mean, so you can see the differences here. And okay, one more point here. If you look at this, there is no kind of outliers here. All of them very close to each other. So this plot even show, this is the density plot. This plot shows that and the distribution of two values almost a normal distribution. So there is no problem with the data set. There is no outliers in the data set. The reason you need to write the density plot is to just show you that how your data is normally distributed, because this is the point. If your data is not normally distributed, if you have a long tail in the first, if your data set, if your density plot squeeze to the left or squeeze to the right, there's two ways. You can just eliminate the tail and see the normal distribution, or if after all of these things nothing happened, you need to go with non-categorical variables. Then the best test is not t-test, is man-Whitley test for two population. This is the point. I think if you are working with this class data set, you more likely 99.9 cannot see kind of tail, very big tail in the data set. So there is not a problem with this class, but in the real environment, make sure always the t-test is not the best test, and you need to see. I'm echoing my, let me sound, so let me mute this. Okay. For the density plot, the first two lines, so the highlighted part is the part you need to change if you like to work with any other data set, any other variables in this current data set or any other data sets. So basically our student call the first line as MDV. You can change it as any name you like, but I do not recommend that. Otherwise you need to change even here and here and here. So if you change the name of variable, you can see the same name plot here, and you can just these are the place you need. For example, if you are going to with diabetes between black and white, you can change the diabetes here with this, and then the name of the topic and this name, and the black and white probably should be the black and white. Let me now go to the RStudio and show you the real environment of this explanation. Here, this is a data set. Can you see my screen, class? Okay, this is the data set, Medicare National Data by County, and I say that this is the second step. I'm going to look at the name of variables. This is the name of variables, and this is the mean comment. I'm going to look at this. These are the means comments. I'm running and I cannot see any result. What is that? Because should something happen to this, data is here, name is here, and what I have to do here if you cannot see the means. Class, do you have any suggestion? Any suggestion? Any guess? No, you are correcting with the name of variables, the name of the package. No, the reason is there are some missing in the data sets, and I need to eliminate those missing. So I have to run with this. I have to add these pieces and not remove if there is not applicable. So if I run that, you can see if you do not have any missing in your data sets, you are okay. You don't need to add an a.remove equal to 3, but It's better to always keep that. If the data has some missing, our studio will consider. If there is no missing in the data set, our studio will not consider them. I will fix also in the PowerPoint for you. These are the mean, these are the standard deviation, this is the number of observation. I can see this number of observation here, 939 for the black and 9037. This is the t-test. The t-test is the equal 0.0018, and this is very small numbers, it's less than 0.05. There is significant differences between black and white population, and so you know how you can drag it to the left and right and see the better, bigger plot here. Now we have to stay here. Come on. Okay. And then the last piece is this one, the density plot. Okay, this is the density plot, and let me go to the Word document here. This is the instruction. You have this table name of the variables, and you can say, okay, black and white, black population, black person. It was the name of variable in the data set is this one, right? You can just put the name here and explanation here. This is white, and then you're gonna say define this. This is a percentage. The description of the code is numeric. Source Medicare national data by country. The year of data set is the year of data set, probably 2013. And then you have one more table like this. This table should be like this table, and this you're gonna report n, mean, standard deviation, and the p-value. And I have the n, I have the mean and the standard deviation, right? You can complete here, but make sure the p-value is only one p-value. In my previous class, some students reported more than 2p, 1p for each of them. You have two population and you have only 1p to compute that. So, and then you can copy the box plot and density plot from the class and explain here. This is as easy as this. It's a very simple process to go, and then just you need to spend a few more hours to make sure everything is in the place. Okay, this is the article part of the codes and the team project. I do suggest all the team members to just go ahead and review document at the very end. Most of the team project has a typos, has some kind of formatting issues, so you need to make sure that you take care of analysis and take care of all pieces. So I do expect all the members have a significant contribution, because at the very end there is a peer evaluation, and all of you gonna grade yourself and your team. Please also put your evaluation for yourself. For example, if you are giving 100% to yourself, please do not exclude that. If you do not give some numbers to yourself and other class give you 80, the average should be 80. So I cannot do anything with that. Make sure for now, for this, pay attention, take care of yourself in this pieces. This is fine. If you want to give yourself 100, this is fine. I'm using the average. The bad point, the negative point is, if you do not receive at least 50% in the peer evaluation, I am so sorry, but I cannot give you any credit for the team project. So the contribution is really, really important piece. Any question for the team project? Sophia, do you have any question? You seems you want to ask something. Okay. State hours, yeah, yeah. Of Yes, well, of course. In this class, we are focusing on RStudio. So the first package is RStudio. But if you are working in some organization, you are a professional analyst, you like to do some work with C++, you want to go with this data, with SAS, this is also okay. But the first software in this class is RStudio, and this is the software we are covering in here because it's a free package. It doesn't need any license, so it's very easy to go. For any other packages, data, SAS, except C, you need to go with a license, and those are really really expensive. For example, I have SAS, annual fee is $900. I have data advance, 2 years fee is at 2400. It's very expensive package. You're welcome. Okay. Okay. If you don't have any other question, I like to go to the week 3 exercise because some students have some problem that with that week. Go ahead, Teresa. Yes. Each member. Yep. You're welcome. Go ahead. It's your. Mm-hmm. 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 Yes, if you like, yeah, yes, yes. You there is two way. You can just run all of them together one time, or you can go step by step and highlight the pieces you want to run and run it. Okay, the variables is here, so you can copy. The variable need to be exactly the same. You can see here. So for that reason, the more conservative way, just copy that. Otherwise, with any small changes, the still cannot recognize that variable. That's the reason I usually copy from here. I'm making sure this is exactly the same of the name of variables, because for example, let me try this. Let me put some space here and see. There still you cannot see the name of variable because only one space here. I need to make sure this is exactly the same name. If it lets me put something like this, I'm copying mistakenly and put something like this here, and usually I'll still give you a message. See, I cannot read this variable. It's still waiting for something else, so I need to remove that. The good thing about RStudio is if you have a mistake here, for example, let me put something here. Usually you can see the message here. See, this is shows that this code, this line of the code has some problem. You need to fix that. This is the message from RStudio, the error message. Yes, please copy from here, then you can make sure this is exactly the same thing. You need to work with that. This is really important. Sure, you're welcome. Okay, any other question? Okay, let me go class to the exercise 3. I think we still have about, yeah, we still have about 11 minutes. The exercise 3, uh, this is exercise 3. You are reading the data here. This is reading the name of data, and this is the data. You are reading this is the name of variables, and here you need to, based on the instruction, you need to generate three variables. I'm creating these variables. And then you can group by Herfindahl index if you are using the Dipler package. So I did not run this package, I have to run this, and then I'm able to do this. Okay. The way I'm generating the code, I convert all the numbers to the Excel file. Maybe you can see here, so in your computer you can you can see, if you just remove this to section from here, you can see the variable, the observation in the console. Let me show you here. You can see them here, and okay, so this is it. This is this. I can see them here. This is the point. You know, this is the place you are generating three data sets, because you are going to run ANOVA tests, and for ANOVA tests you need more than two population. If you generate these three data sets, I generating high underscore compact. This is here, right? This is high here. This is 219 observation. I have moderate. I have here, the moderate is here. Where is that? Here, 1332 observation. I have low compact, and the low compact is here, 1479 observation. So whenever it's happening, so for now I can see everything here. Even I'm able to run a t-test here. I can see the t-test here, right? But this is the point. Is if you now, you know, here in this line 216, I converted the Herfindahl index to a factor variable to run this Herfindahl index. Now if I go back here and generate the data set, look at this. I can see the 0. See? Then you are not able to run the codes. The point is, if you find problem like this, and let me run the codes. If I run the code, I cannot see anything in the codes here. Okay, I'm running, okay, hospital. Maybe I can see, but usually, yeah, I can see that, but let me try to do that. I don't like to, I need to change all of them here. So all of them is 0 now. I am not able to see anything here. Okay, here, come on, it's show. So I don't like to see anything here, but it's anyhow it show me something because I generated the dataset before. But even if you probably should go with my table command, this is a 0. Yes, this is a 0 observation. Yes, this is another place you can check your data set is incorrect. All the numbers here is a 0. So the point is, for this exercise, if you find number of variables, number of data sets 0, has the data set has 0 observation, go back and just run the first 75, 78 lines, something like this, before step 7, and then you're good to go. If you change that, you can see the name observation changed here. I still have some numbers here. This is the point. The other point is, some students try to generate two sync commands. If you by mistake generate two sync commands, whenever you run the codes, you are not able to see any information in the sync command. So you make sure that you have only one sync command here, and the address for the sync command here is a CUMUC, exactly as the address here, CUMUC. If you are working with Mac, it should be tilde documents /UMUC /name of file. Okay, it was a point about the exercise 3. Dr. Azadi, do you have any other question? I don't know if your students are here. Do you have any other questions for that? Yes. Mm-hmm. Okay, did you look at the first 10 lines of your code? Are you sure you have only one sync command? Okay. Okay, you only need one sync command in any place. So if you have any sync, other sync commands, and you make sure the sync command has the same address here as you are reading the data set here. Are you working with Windows? Okay, you make sure this is here, and then try to run all of them now. So also you need to make sure you close the sync here at the very end. Okay. Okay, do you want to try just now to make sure you are okay with that? And before running the code, make sure to mute the install package, not this library, just the install package, because otherwise it take a few more minutes to run. You want to press Ctrl A, run all the codes together, and make sure you have everything in your sync command. And one other point here, whenever you are your sync command has this summarize here, or just you are using write tables for this. For line 32, are you using the summarize command to see the result in console, or no, you are converting the data like I did here to the Excel? What's that? Do you have that part? Do you have this part in your code or no? Can you just read me the summarize command, which is started with this, something like this? No, no, here, just here. After Herfindahl index, you have a summarize right here. Can you see my screen? You have, no, that's okay. You have this one in your code, or you don't have this one? Okay, that's good. That's fine, because if you have this code, you cannot see all the commands in the sync command, all the numbers in the sync. So I'm just muting here in my code event. So do you want to try and run your code and see the results? Are you doing now? Okay. Mm. Yes. 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 Thank you for noticing. Yes. Yes. I explained that whenever you are not grading yourself, and if other student gave you 80 and you're going to give yourself 90, so the average should be 84.5. But if you don't give you any numbers, so I'm gonna stay with average, and I believe you are going with average in your class, correct, Akazadin? Okay. Mm-hmm. And thank you for that. Is exactly happening in my class, same as this. Thank you. Mm-hmm. Is it possible you share your screen? Please do that. Let me stop mine and you share your screen. Class, we are finished with the presentation. If you like to stay, please stay. But if you like to leave, this is fine. I'm just going to answer the question here. Thank you for all of you. Thank you all of you for being here. Okay, sure, you're welcome. Okay, same to you. Okay, Julia, can you go to the very first line of your course, please? Go to the very first line. Okay, see the sync. Oh, you muted the sync comment. Can you remove? Yep. Okay, remove that, please. Okay, and then this is still incorrect. Sync open bracket cumuc slash y. It's happening like this. It should be in some point. Okay, I think the last okay, yeah, that's correct. I'm mistaken, because the last bracket is black. I was thinking it's green. Do you want to run it one more time? Mm-hmm. 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 Yes. No, no, it will overwrite it, but make sure to close the file. Close the text file, I mean, not the codes. And make sure to save your codes also. Okay, now run again. I believe it's working. And that's it. You can just go ahead and open your, okay, it's never mind about this type of error. This is happening for the plots. Okay, I think you have your sync. Can you open that? Okay, you have, and you have the ANOVA test result, I believe so. I explained that there's two Herfindahl index. I use the other one, and for that reason, the p-value with in my p-value should be different with yours. Yeah. Okay. Sure. Okay, doctor. Any other question? Any other explanation? Okay. Okay. Perfect. Okay, class. Do you have any other question for me? Okay, thank you very much. I'm going to save this and just put it. You're welcome and thank you. I'm gonna go ahead and just put it in the class. Have a great day. You're welcome. Thank you for being here, Dr. Azadi. Have a good day. Goodbye. Okay, this is the end of the class and the live session. I'm going to close this and save it. Where is my